In 5.1, what we're going to do is we're going to put some notes to the thing that you were just doing on that investigation worksheet. We started off with investigating, drawing triangles, and this whole chapter, chapter 5, is a formula-based chapter. It's also a calculator chapter because the numbers are going to get really high. And so if you do not have a calculator at home, this is where I'm going to re-emphasize of purchasing your own calculator, because I only have a class set. You can use the ones I have in class, but if you're at home and you're trying to do homework, it may benefit you if you had the same type of calculator that we have in class. So 5.1, we're going to deal with these things called the polygon angle sum theorems. Polygons are named based off of their number of sides, and for this whole chapter, n is going to represent the number of sides. When you see the letter n, it means how many sides does it have. For example, if I see n over here, n is 3, it's a triangle. If n is 4, it's a quadrilateral. If n is 5, it's a pentagon. 6, hexagon, heptagon, octagon, nonagon, and decagon are the ones that have 3 through 10 sides. Anything after that, is usually written as a number. There are some fancy names for them, but our textbook and most other authors will use 11 gon, 12 gon, 20 gon, 25 gon with the actual number in front of a hyphen and a gon, which is kind of nice. You got to know the names to be able to do some problems on your test. You got to know the names to be able to do some problems on your worksheet, just so you know. That's why I had you write down these of the ones you didn't know. The other thing that I need to tell you before I get into these formulas is an interior and an exterior angles are always supplementary. So it doesn't matter what shape you're dealing with. If you have a shape, let's just say I have a shape and I'm just like, I don't know, but the bottom looks like this. This is an interior angle. And if I were to extend this line, this is an exterior angle. Interior angles and exterior angles are always supplementary. That may help you as you're dealing with problems. What we're going to be dealing with is that sometimes we're dealing with some shapes, and sometimes we're going to be finding interior angles inside that polygon, and sometimes we're going to be dealing with exterior angles, dealing with the angle on the outside of that polygon if we were to extend a side of the polygon. Now there are basically 4 formulas that you're going to have to know. The 4 formulas you're going to have to know are right here, and so I hope that you didn't just write down the formula. I hope you wrote down the formula and what you use it for. For a polygon with n sides, the sum of the interior angles of a polygon is this, n minus 2 times 180. We figured that out on our investigation worksheet. Meaning, if I want to know what the sum of all the angles are, all I have to do is subtract 2 of the sides and multiply it by 180 because it's based off of the number of triangles inside that polygon. For a polygon with n sides, the sum of the exterior angles, 1 at each vertex, is 360 degrees. Now this one may confuse you, but if you think about it, if I had, let's just take an object for example, I'll go over here. Let's say I had a 4-sided shape, and it's a weird 4-sided shape, so something like that. Exterior, 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 exterior angle. Exterior angle is this one. Exterior angle is this one, and this one, and this one. If you think about, if I were to make this little 4-sided shape smaller, let's make it smaller, and smaller, and smaller. And even smaller than that, what you would get is something eventually that would look like this. Keep making it smaller, so small that the exterior angle and that exterior angle, that, if you think about that, that is just adding up one rotation. One full rotation is a 360 degrees. That's where that comes from. That'll help us out as we're dealing with problems. Then the next two types of formulas are for something called a regular polygon. When our textbook or when our worksheet says that it's a regular polygon, it means it's perfect. It's equiangular. It's equilateral. It is not like the ones that you drew on your worksheet. Sometimes those were a little bit funky. But what if every angle was the same, and what if every side was the same length? It'd be a perfect regular polygon. Regular means everything is the same size. All sides are the same. All angles are the same. If everything was the same, this is what an individual interior angle would be. Meaning if I had, let's say, a triangle, I have 180 divided by however many sides I have. I could figure out what one of the angles is, and I bet you know that 180 divided by 3 is 60 degrees. It works. How do I find an individual exterior angle? I take 360 and divide it by n, and that's going to help us out as well. So we're going to use these four formulas. We're going to use them a lot. I would recommend that you have your notes out while you do your worksheet. I have several examples picked out for you. 1, 4, 9, and 16 and 19. I have 5 exampple for you. I'm going to suggest, if you would like to do this on your worksheet, you can. Here's number 1. Find the sum of the angle measures of each polygon. Does it say that this is regular? Does it say the word regular at all? We don't know. But it has 1, 2, 3, 4, 5, 6, 7, 8 sides. This is an octagon. You could use the chart that you had that you did before, or we could use the formula. It says the sum. That means all of them added together. It's not an individual, it's a sum. We're going to add them up. So I'm going to go look at my formulas. I need the sum of the interior angles. This formula, n minus 2 times 180. I'm going to write that down real quick. N minus 2 times 180. And since I know that n, the number of sides, is 8, I replace the 2 with an 8, and I'm going to figure this out. You can do this on your calculator if you wanted to, but to save myself punching in some things, I'm going to do the 8 minus 2 part first. 8 subtracted by 2 is 6. When you have parentheses, it means multiply, so this is where I'm going to take my calculator. Multiply it. See what 6 times 180 is. The sum of the angle measures of each polygon is 1080. That's it. Fairly simple. Number 4. Find the measure of one angle in each regular polygon. When it says one angle, that's an individual angle. And it calls this a regular polygon. So I have to remember that I have formulas for the sum of everything, and these ones don't have to be regular, but these formulas only work if it is regular. Okay? I need to find an individual interior angle of a regular polygon. Here's the formula. So I'm going to write down my formula first. I'm going to use the n minus 2 times 180 divided by n formula. Because it says individual or one angle in this polygon. This is a stop sign. This is the same shape that you would see if you were driving down the road. They use the stop sign is an octagon, by the way. How many sides does an octagon have? It has 8 sides. So I plug in the number 8 for n in both. And this is where I'm going to recommend to you, you could do all this individually if you wanted to, but your calculator is really fancy if you have one like I've recommended you buy. You can press a fraction button right there. Let me bring this a little closer. Here's the fraction button right there that I'm pointing at. And then that brings up the fraction, and you can actually use parentheses and do 8 minus 2. It's going to do that first. And then you can put the 180 next to it. It knows to multiply it, I think. Let's see. No, it doesn't know to multiply it. And he goes, what do you want me to do with it? 8 minus 2 times 180. And then press equals. And what this tells you is the individual angle of an octagon is 135 degrees. If you had 8 of those things, you should get that 1080 we found before. This is also helpful if you ever need to in your life. Oh, I need to make an octagon out of a piece of wood. I want to make your own poker table. I don't know. Maybe someday you do. I like poker. There you go. Maybe someday I'll make my own octagon. Anyhow, number 9. Find the missing angle measures. Let's take this up a notch a little bit. If this is asking you to find the missing angle measures, this is where it gets a lot harder, as a matter of fact. They throw in 5x plus 5, 4x minus 10, 4x plus 15, 4x plus 15, 4x minus 10. And you got to go like, wait, how do I figure out what it is? Well, you use the sides. I have 1, 2, 3, 4, 5 different sides. Do you notice that the angles are not all the same? They're not all the same, so that means this is not regular. This means that I'm going to be using these formulas up here at the top. Which one am I going to do? Are these interior angles or exterior angles? Oh, they're inside. I'm going to use the interior angles. I need to use this formula somehow. So the first thing I do is I'm going to figure out what is the sum of all of these angles using the outside. I plug in the number 5 because this is a pentagon. It has 5 sides. So I know that the sum should be 5 minus 2 times 180. I don't know what that is, so I'm going to use my calculator. 5 minus 2 is 3 times 180 is 540 degrees. Once you figure out that these should all add up to 540, then that's what you do. You go and take the 5x plus 5, and you're going to add the 4x minus 10, and you're going to add the 4x plus 15, and you're going to add the 4x plus 15, and you're going to add the 4x minus 10. And all of those should add up to 540 degrees. Now let's just kind of do that together. 5, 4, 4, 4, and 4. How many x's do I have altogether? Say it out loud.
21.
Ooh, 2 of you know. 21x. Love it. Now this is where sometimes you use a calculator, sometimes I don't. 5 minus 10 plus 15 plus 15 minus 10. If you need a calculator, just plug that in. 5 minus 10 plus 15 plus 15 minus 10. Just because there's a lot. And that's what I like about these calculators. You can see, did I type it in correctly? Equals, it's a positive 15 left over when you put all that together. And now let's just solve that. 21x plus 15 equals 540. I subtract 15. I'm going to use my calculator. 540 minus 15 is 525. 21x equals 525. Divide by 21. Divide by 21. X is going to be 25 is what I'm getting. Now, did I answer the question? Let's go back. Find the missing angle measures. I found x. Did I find the missing angle measures? No, I did not. What does that mean? I need to take this and I need to plug it back in so that I can figure out what each of these measures are. So I'm going to plug the 25 into each of these. 5 times 25 plus 5. This is why it's a calculator unit. You got to plug things in and figure it out. 5 quarters is 125 plus 5 is 130. Let me double check that mathematics real quick. 5 times 25 plus 5, because I did that in my head. Yep, I was right, 130. 4 times 25 is 100 minus that is 90. That's 2 of those. 90 over here, 90 over here. 4 times 25 is 100 plus it is 115. And 115. Now if I did this right, all 5 of these should add up to 540. Because I like to check myself, what I'm going to do right now is press 130 plus 90 plus 90 plus 115 plus 115. And I wanted to just double check myself. It does add up to 540 degrees. It works. I know I'm right. It's nice. Which brings us to our last 2 examples. I have 16 and 19 are the last 2 I'm going to do with you. Number 16 says, the measure of an exterior angle of a regular polygon is given. Find the measure of an interior angle, then find the number of sides. Well, here's what I want you to think of. Just like I drew that picture before, there's some polygon, we don't know how many sides it is, and an exterior angle is 120 degrees. This is not a really good picture for it, but here you go. This is an exterior angle. It's outside of this polygon. Find the interior angle. Well, these are supplementary. We wrote that down in our notes. So what does that mean? That means I need to take this away from 180 degrees to figure out what's the interior angle. 180 minus 120 is 60. That's our interior angle. And I think the easiest way to find the number of sides is to use that last formula, since this is a regular polygon. Regular polygon. It's easier to use the easier formula of 360 divided by n is an individual exterior angle. So I'm going to write this down. The exterior angle is equal to 360 over n. Let's write that down, and I'm going to show you how I use it. Exterior, individual, exterior angle. I'm going to call that E. Equals 360 divided by n. 360 divided by n. Do I know what the individual exterior angle is? It gave it to me. It says it's 120 degrees. So I'm going to change that to 120 is equal to 360 divided by n. What I am going to do is I'm going to do a 2-sided move here. I'm going to do this the long way, then I'm going to show you the short way. Here's the long way. You multiply by n. You multiply by n. 120n equals 360. And then what you do is you divide by 120 and you divide by 120 to get n by itself. The short way, going back over here, the short way is when you have a variable on bottom. It only works when the variable's on bottom. You can just switch these 2 places. Think of it as a proportion. And this is this over that, and those 2 things can switch with each other. And I can do n equals 360 divided by 120. Same answer. 360 divided by 120, I'll do it on my calculator, is 3. That's how many sides there are. It's a triangle. Which should make sense to you. because 120 makes it an equilateral triangle, right? If they're all 60 and they're all 60. I'm hoping that picture makes more sense with you after that. Last example. A regular polygon has an interior angle with a measure of 150. How many sides does the polygon have? We could use the individual interior angle, but I am a person who likes to use the exterior angles to figure this out. So because it has an interior angle of 150, I usually will figure out what's the exterior angle. A lot of times I will do 180 minus 150. Now I know what the exterior angle is, and it's a regular polygon. That 30 degrees should be equal to 360 degrees divided by n. I'm using that individual exterior angle formula. You can do the long way, multiply by n, then divide by 30, or you can do the switcheroo. And you can actually figure out how many sides it is by doing 360 divided by 30. And you only do the switcheroo when the variable's on bottom. 3 goes into 36 12 times. How many sides does a polygon have? It has 12 sides is our answer. I'm going to stop your notes right there.